We move into our second keynote for this morning. And our keynote speaker this morning is Nivruti Rai, Vice President, Data Center Group, Country Head, Intel India. A very brief introduction before I invite her on stage. Nivruti Rai, like I mentioned, is Vice President in the Data Center Group and Country Head, Intel India at Intel Corporation. Based in Bengaluru, she provides overall engineering and business unit leadership and leads operations for the site, driving innovation, cross-group efficiencies, and execution for engineering teams delivering global products and roadmaps. She also leads engagements with national and local governments and policymakers, as well as collaboration with ecosystem players to enable innovation and entrepreneurship. Ladies and gentlemen, please extend a very warm welcome this morning to Ms. Nivruti Rai.
Very good morning. We saw a wonderful presentation by Dr. Omkaram and how he talked about some of the applied materials innovation is fundamental to growth. I'm going to take it a little bit forward, looking at some of the basic fundamental innovations to innovations and inventions that drive use cases, that drive products that impact our lives on a daily basis. So before I start, my introduction you heard, but truly, I will consider myself successful if I'm able to drive. I stands for Intel, I stands for innovation, and I stands for India. Innovation is going to be binding between Intel and India, and that's when I will consider myself that my job is done. What I'm going to talk about is what are some of the technologies that are going to power the future. Some of the technologies you've already heard in terms of day in, day out, what India is trying to drive, digitization. We know about the unique identification. We know 1.2 billion people have biometric-based digital identity. Data is going to be flying everywhere. The amount of average internet user, 1.5 gigabit on a daily basis. Autonomous vehicles, 4 terabyte, and so on. You will forget the number of zeros that come beyond tera and then zeta. I will share with you, by the year 2020, our assumption is we will have 50 billion connected devices. Now, these 50 billion connected devices will generate data to the order of 160 zettabytes. And most of you are engineers, but for the benefit of people who are non-engineers, zeta has 21 zeros behind it. That's the order of data that we are dealing with. And some of the examples that I've listed here is in the space of autonomous vehicles, in the space of connected airplane, in industries, as well as cloud videos. The amount of innovations our telcos are driving, game-changing innovations by Reliance. So I don't have to prove to you that the world of tomorrow will deal with data as the new oil or data as the new currency. What is Intel? Since I am, been in Intel for the last 24, 25 years, I know Intel stands for innovation. The areas that we are investing in is whole lots of things and devices. The change, the new avatar that Intel has taken is that the devices comprise of many different form factors. You can see, we have industries, we have cars, we have homes, we have desktops, we have mobile phones, we have laptops. All kinds of different computes is what we call things and devices. Now, all of these things and devices, if they don't have connectivity, how and what good use can they provide? So what is absolutely critical is connectivity. Connectivity, today we can experience 3G, 4G, but we are aspiring to go into 5G. We are looking at, wireless technologies. We are looking at other interesting technologies that can be leveraged, even, in the space of leveraging quantum physics in the use case for, driving internet. Connecting a lot of our things, devices, is the cloud. Cloud will have a lot of ability for storage, analytics, whether it is based on artificial intelligence or not. It has a lot of analytical capability, as well as, networks. So the whole connection that you see in this circle, we call it virtuous connectivity, which enables growth. Technology will deliver amazing user experience. So we heard fundamental technologies, and now we're going to look into technologies that translate into user experience. Now, what are some of the innovations? I already listed some, in my previous slide, or at least I talked about it. But recently I was in Hyderabad, and just like, we hear data is the new oil, Professor Andrew Ng, who's supposed to be the godfather of artificial intelligence, I'm sure if I have the raise of hands, how many of you know Andrew Ng, at least by the work he's done? That's what I was expecting, from an IESA conference. He said, AI is the new electricity. It is as essential to the needs like electricity was so many years ago. So AI is going to be everywhere. AI will be at all form factors, whether it is sitting in your pocket, whether it is plugged on the wall of your home, whether it is sitting on your desk, AI will be everywhere. AI will be leveraged wherever there is some amount of thinking required, as well as compute required. And I'm going to share, one more quote from Dr. Andrew Ng, because it was the most exciting presentation I've ever witnessed in my life. Very basic, very simple, very useful. You know what he said? Artificial intelligence is a technology which will replace the thinking that we do in the order of 1 second. If it takes you 1 second to think, let me just see, what was that fruit again called? It was called persimmon. If it takes you 1 second, then today's artificial intelligence technologies, machine learning capabilities can replace it. And tomorrow, it's going to be better, bigger, faster. The artificial intelligence will be creating different verticals, powering different use cases, whether it is in the space of autonomous driving, changing the lives of people, whether it is in the space of health, or as well as entertainment. I'm going to add on to some more technologies. Today, Intel is working heavily on completely re-architecting memory solutions. Many of you, have heard of neuromorphic computing. Just very simply, for the 20-30% of people here who are non-engineers, what is the difference between the typical architecture of computing versus neuromorphic? Neuromorphic uses a different compute architecture, and it is not based on von Neumann architecture. Now, don't be scared by the von Neumann name for the people who have not heard of it. Von Neumann simply says data, it can be stored or handled in 2 ways, through your CPU or through the memory. And they are located, apart from each other. What neuromorphic computing does, it says, the latency is not what I want. Nothing is really real time because data is being accessed from the memory and the CPU is doing the compute. So what they did is, hey, I'm going to bring the CPU and the memory in a unit, and they have, small unit of processing where they do computing, where they have memory, and they have the ability to transmit. So neuromorphic core tries to emulate the brain, where we have literally thousands. So if you look at IBM's True North, there are 4,000 processors, 1 million neurons, and about 250 synapses, the connections. So those are the kind of computing that will be the technologies which will power our tomorrow. And we've got to invest in it today. Also, quantum computing. How many of you have heard of what China did recently, enabling, quantum photon transmission to the order of 900 miles. Most all of you have heard, right? Can you have a show of hands? Oh, okay, not so many. Okay, so what China did is they enabled a quantum satellite. What that did is entangle two photons, not people, not any other information, not particles, not electrons, because electrons need a lot of supercooling. They actually entangled two photons. Now, entangling of photons, what it does is it creates identical behaviors in two photons. Now, one photon is sitting here, the other photon is 900 miles, exhibiting the exact same characteristics. Imagine what this can do to our internet. If our quantum computing enables internet, all your downloads will be instant, because there's a photon here, there's a photon 900 miles, exhibiting identical properties. So the future, which has to build on technologies like this, needs investment today. And I'm very happy to tell that Intel is one of the very many companies whose DNA is invention and innovation is driving efforts in this area. Also, another critical thing is, we are talking about use cases coming from artificial intelligence in various different verticals, whether it's health or autonomous driving or entertainment. There's another capability that we are heavily investing in, based on the acquisition that we made, is enabling acceleration through FPGAs, field programmable grid arrays. A lot of machine learning-based computing can be made efficient, faster, real-time, leveraging FPGAs. Otherwise, what happens? Of course, machine learning can be done and solved by a CPU or GPU, or we have ASICs, which are built for machine learning. But if you use an FPGA with machine learning capability, it will enhance the current compute, whichever form factor of compute you have. And it can be sitting in your automotives, or it can be sitting in your health kind of clouds, etc. So Intel is heavily investing in memory and FPGA, primarily to make the compute instant and to make the use cases generic enough to be leveraged in multiple different verticals. I already told you that the future, not so far away, 2020, will have 50 billion connected devices. And just to remind you again, 160 zettabytes of data, 21 zeros, in the air. There's no way that our current technologies like 2G, 3G, LTE can enable support. Even 5G is looking like 10 gigabits per second. And with the current use case that we are thinking, we've already utilized the 10 gigabits per second. But we know that 5G will evolve, it will have much more capability, etc. And just to tell you, 5G is not the typical evolution of 2G to 3G, 3G to 4G. It's a basket of technologies enabling very many different connectivities. Whether it is a V2V, vehicle to vehicle, it's an M2M, or the standard use case that we like to enable through our phones, etc. So it's a basket of technologies, and we need nothing short of 5G here in India as well. So exciting times for us ahead. Which other forum to ask more than IESA and the members here and the visitors here to look into investing more and more energy and efforts into these areas? These will power our tomorrow. And our tomorrow cannot be later than the tomorrow of Israel or the tomorrow of United States or the tomorrow of Japan. We want to be on time with our innovation such that we can impact the lives of our people. I'll just tell you one example on this autonomous driving and why it is so important. So many times people come and say, hey, Nivruti, you guys are investing so much into autonomous driving. That is just enabling comfort. I'm saying, sorry, it's not just enabling comfort. Do you know that in 1 hour in India alone, 17 people will die of traffic accidents? Of the 17 people that will die in the next hour, 75% will be the youth and men less than the age of 25, who had a very long life to live and enjoy with their family and the world. That is what we intend to solve. Deaths on the traffic happen because of human error and infrastructure. And I will tell you that the efforts that we are making as Intel, we are making in partnership with others, will resolve some of these. And I will give you a little more detail in the next slide, hopefully. Our goal, and when I say our goal, I'm talking about all of us, not just Intel, is to innovate and address the challenges that we are living in. If truly there are bots that in literally minutes can kill cancer, why shouldn't we save the people who are ailing in our families, our friends, our country, who are suffering from cancer? It's our responsibility as technologists to drive some of these innovations, to drive the changes that impacts the life of people. For a moment, this group has to think beyond themselves and think the world and think the people, what your effort can do in terms of changing the lives of the people. Let me just tell you a few things. I already talked about how many road accidents. Let me just add some more statistic to it. The world sees 170 deaths in 1 hour. And remember, I told you India sees 17. 10% of the accidents are happening in India, and I can assure you, 10% of the vehicles are not running here. We are leveraging our technologies to enable solving the human error as well as the infrastructure error. The technology that is fueling this product within Intel that we are trying to drive is based on artificial intelligence. Artificial intelligence, which gives the machine an ability to process, an ability to see. If you can see and process, and remember the rule of thumb, 1 second, the machine can do better than you because it has the access of eyes behind, which we don't. So we are actually leveraging our Mobileye Intel product that enables computer vision along with display, adding on top of it the local requirements. I was just talking to Dana here, who's, I'm very fortunate she's part of the guest. I was telling her, in India, lane departure, who cares? But we do care that a little child is crossing a highway where there's no zebra crossing or anything meant. We do need to know. We need to know that a bicycle or a motorbike biker without a helmet, in our blind zone, we can't see. All of those changes or localizations we are making on this solution. We will equip some cars. There's a pilot that we've begun thanks to the state government of Karnataka and the IT minister, who has enabled us to show a pilot on certain number of vehicles which will be equipped with our solution. And we will give notifications to drivers on certain things that he or she cannot see or visualize or enact upon, and also create what we call gray maps. Gray maps is based on GPS and XY location, which will color a spot based on different colors. How much is the likelihood of an accident here based on the infrastructure issues? So we've already started collecting data, huge amount of data. You already saw autonomous driving, some 4 or 5 terabytes of data. We started collecting the data to help solve infrastructure-related issues. Where are the roads that don't have the banking for turning? Where are the roads which are hugely dug up, which will create? So those are some of the criteria that will create a gray zone. Now, gray is something highly likely accident can happen. Black is accidents have happened. White is good to go. Huge amount of data. We will ensure that all of this data is available to our academia as well as our researchers, as well as our startups. So that's some engagement that Intel is driving. And honestly, for this one, it is, of course, Intel is a profit-making company, but we have a social delivery also that we are working towards. I also want to tell you another thing that Intel is trying to do. We're calling it City Stack. City Stack is nothing but a software stack which enables edge to cloud, creating the data, storing the data, and everything in between, such that academia, startups, other industry consortium, other countries can access the data to create use cases. For example, autonomous driving data is being run through City Stack and made available to everyone. One interesting startup that a finance guy came to me, and I was saying, okay, this is excellent. Intel finance guy, he told me, hey, Nivruti, if you have a data set like this, I'm sitting here in Leela driving this conference, and this was a US use case, and I really got confused whether I actually shut the garage door or not. Live data on this can actually zoom into Bryce's house and say, oh, his garage door is closed. So a lot of services, interesting services can come out. This is just one example. Infrastructure, which is a more critical one, I already talked about. So we are building City Stack, which will have APIs to pull in data and APIs to provide data. And I have to thank Eka, which is our partner company, Manav Garg, especially, who's the CEO and founder of the company. We're working together to create this City Stack, very akin to what India Stack looks like. And some examples are, we're looking at air and water quality monitoring data going through City Stack and being stored in the cloud. So some of the examples you will see, and then you can look at interaction. Is there health-related data and traffic-related data? Is there a dirt-related data in a certain neighborhood associated with diseases which can be increased because of the dirt in that neighborhood? All of that connections can be made if you have data stored in a manner consistently, whether it's coming from traffic, whether it's coming from the hygiene and cleanliness, or it's coming from air and water quality monitoring. We will enable this data such that we can drive scalable solutions to power growth as well as power the ecosystem and drive changes to the lives of our people. I want to finish this with, like I said, Intel is synonymous to innovation and invention. I want to see India being synonymous to innovation and invention, and therefore creating impacts to the lives of the people, impact to each and every one of us as well as our country. If we even aspire to be what China is and aspires to be, China is expecting 25% of GDP growth coming only from artificial intelligence powered technologies. We today are in the rest of the world, which is 5% or less. I want to encourage each and every one of you to drive areas leveraging machine learning, artificial intelligence in whichever use case, even, for example, doing your own VLSI design, even leveraging tools better. There's application of AI everywhere. What we have to do is drive focus. Rather than drive 105 different things, focus on 2 to 3 areas you, your company, your academia, your government wants to invest in. Drive technology, because unless your solutions are driven by technology, and you partner with someone if you don't have the technology, make sure that you have the policy support, with things like drones, for things like AR, VR, even for autonomous driving. We have to ensure that policy comes with us. We have to think big. We really have to think big. I am tired of this word called jugaad, because jugaad brings me down. Jugaad is like a make-do band-aid innovation. While it is good, but if it is blocking the big innovations that can drive big changes, then I have a problem with it. And sometimes I do see people getting happier with jugaad, but not focusing on the true innovation and invention which will drive impact. Lastly, and I'll finish with this. The world of today is based on solutions that will not come from one single company or one single source. We have to partner. Intel today is a different Intel. We are partnering with companies like BMW. The world knows about it. We are partnering with, telco providers because the needs of today is the need of a solution which requires collaboration. Because end-to-end is what drives impact to us as users. So thank you very much, and I'm looking for more collaboration, more inventions, more futuristic technologies, and helping me and helping all of you drive I stands for India and I stands for innovation. Thank you.
I'd like to request Mr. Niranjan Paul, IASA Executive Council member, to please come forward and present Ms. Nivruti Rai with a small token of our appreciation. Ladies and gentlemen, we'd like to request you to kindly remain seated.